The following presentation is for Nexio's BAT-EMC software. We are going to perform a conducted emissions test according to the CISPR standard. In this instance, we're going to show two different ways of doing that, one with an FFT receiver and one without. You can see that we have a project already open. This project was created from a template. That template was one that was validated when the Nexio personnel were first on site, and when Nexio did the training and assisted the customer in setting it up exactly according to the standard and exactly according to their preference. This test has two different subranges, one for line 1 and one for neutral, in the range of 150 kHz to 30 MHz. If I open up one of these subranges, you can see the start-stop frequency, the comment that we're on line 1, the step size is 1/2 the resolution bandwidth, and we're using linear scan mode for the receiver. The equipment setup is chosen, as well as line 1. I go to settings, you can see all these parameters are captured and reflect what is in the standard, such as the resolution bandwidth of 9K, the measurement time or dwell time for the receiver of 0.5 milliseconds per step, and so on. The procedure tab will show that I'm only going to use the peak detector for my first measurements. I'm going to use my advanced suspects routine in order to filter out these pre-scan measurements. I'm going to compare that to the average limit line with an offset of -6, and you can see that we'll have a peak detection of 6, which means 6 dB above the noise floor, and we're going to look for the 10 highest peaks. Once we acquire those peaks, we're going to transfer them to a table of suspects. Once transferred to a table of suspects, we can then do final measurements. This shows the measurement time of 15 seconds for unsteady disturbances. And then we will do the frequency drift check to make sure that we're centered on the right frequency before we do the final measurements using the quasi-peak detector and the average. Here, this is our chance to organize the data into particular columns and to set up the column names exactly the way the customer wants. So, clicking back at that stage, we can select execute to start the test. And you can see we have the two different limit lines for quasi-peak and average. I will select yes. And yes, I will stay in simulation mode. You can see that whenever there are multiple resources available, they can be chosen here, in which case I'm going to use the ESR, and this is for the pulse limiter for the input protection in the front panel. I can select OK. It prompts you to move to line 1. If we had a listen that could be controlled automatically, it would have controlled it. It did the initial pre-scan. Now we move on to neutral, and there we go. We have the measurements here for the pre-scan, and we have the measurements here for the final scan. We have the table called final QP and average that was created according to the advanced finals routine. One thing to note is that we had the ability to control all of the colors on the graph. We could have changed the colors for the pre-scan peaks between line 1 and neutral, controlled the cursors, the colors that go to the printer as well as the ones that appear on the screen, and so forth. Once colors are chosen, you can save them as or memorize them as default. So there you have a completed conducted test. I will close this test, and then we can attempt the same test in FFT mode. By clicking on this test, I can open up the first subrange and we can see the differences. Primarily, we will use the quasi-peak detector and the CISPR average detector simultaneously for the pre-scan, rather than doing a pre-scan and peak and having to remeasure later. That's the beauty of a fast FFT receiver. For the advanced suspects, the difference will be we will compare the CISPR average detector measurements according to the average limit line, and then the quasi-peak measurements according to the quasi-peak line. Once again, simultaneously. The settings are as before. The difference will be we will choose FFT mode, and when choosing FFT mode, the step size becomes 1/4 of the resolution bandwidth, not half. Now I will execute the test. I will stay in simulation mode. It will verify the right resources are chosen, and I can select OK. First, we do the line 1 and then neutral. You can see the results are completed. We have a table for the CISPR average, and we have a table for the quasi-peak. Now, in real time, this would have been much faster using the FFT mode. Under simulation, it was shown as quite fast for the regular mode, but in real life, it would be much slower using the linear scan versus the FFT. And in fact, FFT mode, an FFT window is large enough to fit in about half of the entire subrange, in which case it would take 2 FFT snapshots or 2 FFT windows to make the complete measurements. One other thing to show, which is to verify that indeed we were doing the correct measurement time, because once again using both detectors in final measurement, I wanted to prove that we chose 15 seconds. So indeed that is a huge advantage of performing FFT measurements. Now that we have completed test, we can generate a report. Let's generate a report for this test. If I was to right-click on that, I can choose the report. The dialog box will appear so I can choose the right template. Here I have one that was already created. I will select open, and then it will give me a chance to give it a name. Here I have one already started. I will just simply make it number 2, and I can select save. Then it will extract all the information and generate a report. I will pause while we wait for the report to be completed. Now you can see the completed report. If I filled in all these details, it would have been inserted here. And if I were to scroll down, I can see the test information that could have been filled in completely. There's information regarding the subranges, the settings, and you can see the list of equipment used. Here we have the graph for the entire range, the individual subranges, and all the way downwards we have the completed information. If you note, the section up here is the legend so that you can define what these colors mean for the markers and the limit lines and so forth. The tabular results are shown below. This concludes the Nexio presentation. Please be sure to check out our other presentations on other subject matter, as well as a variety of test cases. Thanks for your attention.